Hey everybody, Adam Savage here in my cave with another one-day build. I was about to shoot a show and tell because I got some lovely stuff from a fan, and it includes some exceedingly tiny parts, which you can barely even see at the bottom of this case. These are screws so small, I almost can't resolve them with my eye. But I have a piece of equipment that might be able to. However, I think it's missing a key thing that I'm going to need to add to it, and that is today's one-day build. Let's go get this piece of equipment and set it up. Part one. Yes. Yes. A part inspection microscope. All right. So this is something I bought back during the Mythbuster days when I needed it for one of our experiments. And okay, so this is an inspection microscope. Ooh. Yeah, I guess it just does that. Right, I need to see what its focal distance is. Let's see here. There we go. Ooh, okay, it's about there, so it's a little lower. Bring this down, and yeah, look at that. Oh man. Okay, so my issue is this, like gotta do this. And the fact is, back when I got this, I had another piece of equipment that I'd always intended on adding to it, and that was this. This is a fiber optic ring light. So when I attach it to, look at that, see that? Yeah. This is a really nice piece of equipment. Super soft fiber optic, lots of thin lines, and I put a bright light source up to this and mount it right here, and I get a really, really nice inspection microscope. But I never got around to doing that, and it didn't even occur to me that I hadn't gotten around to doing that until I got those tiny parts, and I thought, oh, well, let me pull out the microscope and take, and I remembered. So what is the light source for this? I'm glad you asked. It's here in my microscope box. I've got a fiber optic light box. Yeah. Let's see here. There we go. If I connect, let's see here. Huh. I think somehow power is messed up here. The reason I think that there's something wonky with the power is the fan doesn't start up when I turn it on. There's no other switch besides this min-max switch here. And I'm having trouble opening this all the way. Oh, I guess it looks suspiciously like a switch in there. Big power supply, fan motor, a big fat switch. Ah! It had just not been closed. Well, sometimes the solution is easy. So this has a safety in that it won't go on until you've actually closed it. And yeah, there's the fan going. Okay, cool. Well, that was an easy fix. So let's put it all the way to min. We will tighten it up. And then there we go. Okay, so here's how this works. The fiber optic goes in here, you turn it on. Look at that. What? Oh yeah, dude. This is amazing. It's a cold light. I mean, actually, you can feel the UV just from the ultraviolet, but it's a fabulous light. I actually have 2 of these because, well, you know, at one point I was making television money. So what I'd like to do is connect up this ring light to this microscope. And to do that, I've got this bottom here, and I need to machine a coupling for this bottom. This is actually kind of cool. Check this out. This interior ring here is actually threaded. And that leads me to believe that I might be able to figure out its threading and make a little coupler out of Delrin that connects up to this. This has just 3 tightening thumb screws there that hold it down, these little bits of nylon. It's missing one, but I've got more of those. So yeah, today's one-day build, attaching this ring light to this microscope. Let's get started. I think the first thing I want to do is pull off this shroud. Ooh, there you go. I want to pull off, I need a bigger screwdriver. I want to pull off this shroud, and then I can work on it in peace without having to worry about harming the rest of the microscope. It's actually a really nice Bausch & Lomb microscope with a reasonable depth of field. One of the things I do when I am taking something apart is, as I pull out screws, I put them in the orientation on the table that they were in on the device. I learned this from Robert Pirsig, San Francisco native, and I think he's San Francisco native. I could be wrong. No, Bozeman native. Anyway, Robert Pirsig, who wrote Zen and the Art of Motorcycle Maintenance, talked about doing that. And ever since I read that, I was like, oh yeah, I should totally be doing that. Okay, so. Oh. It seems I have removed something different than I thought I was removing. But that's okay. That's all right. Ooh, okay. So now I see what I've got here. That lives there. And yeah, this is just a zinc pot metal thing. Wait a second. How do you? That's it. Look at that. Okay, cool. So obviously this whole thing is removable. It went in like this, which means that this is the front. I'm just going to label that so I don't forget. Nice piece of Delrin. I don't need it to be that thick, right? I just need it to be like that plus that. So let's say 0.6 inches thick. So I'll cut myself a little chunk of this. Are you quite finished? A note I wanted to say about cutting into round material on a bandsaw. Be careful. The reason is that bandsaw, depending on the blade you've got in there, can be very bitey, especially on certain materials. Delrin is super bitey. It's soft. It grabs. Brass is another one that's very much like that. And there are times when you might be cutting something and go like this and it spins on you. And anything that's going to move in a way you didn't expect is the thing that could help introduce your flesh to a blade, and that is bad. So, round material. I have it sometimes when I've had to cut larger round things, have actually clamped flats to them so they can't spin. But this, I know that I just changed out this blade. It's nice and sharp, and this Delrin is soft and good, so we're also. But I know that this blade is nice and sharp. I just put it in, and Delrin can be handled by this blade, so I didn't have to worry. And it's like nice mass. But PVC pipe is another one that can spin on you. Don't want that. I thought I was shooting, but I wasn't. I just faced off the front of this guy on the lathe, and now I'm going to drill the first hole. And to do that, I'm going to use this Forstner bit to drill the hole. So this Forstner bit, you can see, it's about 1/4 of an inch less in diameter than this ring light, and that's great for me. That gives me some meat that I can grab onto, and I'm probably going to go just to slightly less than the depth of the Forstner bit here. So here we go. Forstner bits need a lot of pressure to work, so they can move things on your lathe. Tighten stuff down really tight. Yeah, that's great. Swap out my live center for an actual drill chuck. So, you know what? I prefer the big Jacobs chucks for these, simply because sometimes when you put a lot of pressure on a thing like a Forstner bit in a keyless chuck, it can put so much pressure on the keyless chuck it gets stuck closed, and that's bad. All right. Lovely. All right. I'm going to leave that chuck in there because we're going to drill a smaller hole right away. Now, the smaller hole needs to be able to be turned down enough that I can kind of pressure fit it into threading here. I'm not going to cut the threads. These are way small, and I don't need to worry about that. This is not a precision instrument I'm making, but you can see that the Forstner bit size gives me a little bit of meat. Yeah, this isn't a high pressure situation, so I don't need much more meat than that. Oh, here we go. Whoops. Okay. And this one, I'm going to go probably about the same amount of distance here. It's cutting beautifully. However, I want to point out that, remember I made some marks? That's how much the pressure of the Forstner bit has pushed my work back into this. Now, I should still be okay with that because I don't need a huge amount of material, but I am going to push this back out and reclamp it. If you really don't want it to move, you can back it sometimes with something that will prevent that material from going. And I could have done that, and I have done it, but it wasn't that important for this one. So now, I'm going to go that a little bit farther. All right, so now let's just see how that turns. That's fine. All right, so now I'm going to, is that fine? I feel like I could. Yeah, that's good enough. Okay, so I am going to use where is it? Here's one of my Aloris universal bits. There we go. That's the one. This might be my all-time favorite lathe tool. This is an Aloris CRT 20. It uses a carbide insert that is indexable. So when you beat this insert up, you can turn it to the next one and to the next one and on the other side. So you get 6 cutting surfaces per insert, and you can adjust this to any angle you want or to a whole bunch of different angles. It's fabulous when you're doing a lot of aesthetic work. So here we are. I'm going to just lay down. Oh, right. I have to lay it down to a specific diameter, and that's this diameter. But what is that diameter? So I've got the thing I want to measure. I've got my telescoping gauge. I compress the gauge as far as I can go. I put it into the middle. And, ooh, there we go. Now, ooh, that's it. Okay, so I tighten up the gauge with it off angle, and then I bring it into level, and that pressures the pieces. Yes, there we go. Cool. And that tells me the overall, this thing isn't perfectly round. That's fascinating, but it's close enough. Yeah. So that is the distance I'm going to be working with. And that distance is 2.4. 2.4. I'm going to think that it's 2.4. Engineers, big companies like nice round numbers, and I'll wager that's exactly what that was. So 2.4 is my goal. So this is something that I do a lot. When I want to come up with a critical measurement. Oh, come on. When I want to come up with a critical measurement for something like this, and I want to cut it down to 1, here's what I'll do. I will actually bring a tool in, and knowing that I'm under the, at a comfortable place, I'll just take off a little bit. There we go. You see that? Yeah, now you can see that. Okay. So I haven't moved the cross slide. What happens is if I measure this, and it says that it is 3. Wait a second. Where am I at? 2.4. That's where I'm at. That's what I want. 2.4. And right now, this thing is at pretty much exactly 3 inches, give or take 5 thou. So this is 3 inches in diameter. Then I set my cross feed to 0, and I know that I need to take 600 thousandths out of that, 0.6 inches. Delrin is pretty soft and easy to machine, so I'm going to go in 2 passes of 300 thousandths each. Oh, lock down my tool post. Delrin can be grippy, and it also can create ribbons that get tied up and will start smacking you in the face. Yeah, look at that. Whee! Woo! Yeah. But you got to be gentle with Delrin. It'll bite you. It'll jump out of the. You try and bite into it too hard, it'll jump right out of your chuck. Nobody wants that. All right. So just to double check, I took 300 some odd thousandths out, and now I am at 2.7. Yep. Okay. So I'm right in the zone. There are many cases in which I would get more exacting about this, but I don't need to be here. So here we go. I'm going to go all the way to 600 thousandths. Up there, that top number. Oh, my cross slide is so precise right now. It's a beautiful thing. So here we go. And I would use the auto feed, but again, it would create these long ribbons, and I don't like that. Every time you stop, the chip breaks, the ribbon breaks, and you want that. I don't want these ribbons fighting into me or flying around. Now I'm just going to face this because when I mounted it, it was a little bit. You hear that? That's it being off by about 2 or 3 thou. There. Now it's good. Okay. Let's chamfer the edge. Let's measure it out. Look at that. 2.4 exactly. Okay. 2.42. That means that this should fit really nicely on there. Oh. That is nice. All right. So then, now I need to cut the second cut. And I'm going to use a different tool for this. I'm going to kind of do a... Do I even have one? About to do a little bit of some quick and dirty kind of special effects type of lathe work here. So don't take it personal. Please don't be upset with me, machinists of the world. Because I'm working with Delrin, I have a lot of latitude, material latitude. So what I need to do now is on the back side of this, I need to actually, let me get the, here. I've got this step right here, that step. And when I laid the outside of the interior of that step, it's going to hopefully thread or fit, pressure fit right into this ring on the bottom of the microscope. So I need to know the diameter of that, like exactly how big that is. And I also need to know where to start my plunge tool. And I'm going to basically be using my thick cutoff tool to make this measurement. And I'll show you how I do it. So here's how this whole measurement thing works. I got to figure out where to start my tool. And I'm going to do that with a depthing tool here. So this is a pair of calipers. And if you've handled a pair of calipers, you know that not only do they measure outside diameters with the jaws, they measure inside diameters with the little tails behind the jaws. Not super high precision, but plenty good enough for commercial special effects work. And then there is this, this depthing tool, and that's what I'm going to use here. I'm going to put that up in here. I didn't even need to know the measurement, but I can set my lathe tool to be exactly that correct distance, right? So I've zeroed out my CNC over there, my DRO, and I need to get from 4.2, the measurement of this, to 1.52, the outside measurement, the inside measurement of this. And when I do the calculator, 4.2 minus 1.52, that tells me I need to take, not really 4.2. Am I totally insane? Yes, I am. It's not 4.2, it's 2.4. This is how mistakes are made. 2.4 minus 1.52 equals 0.88. That sounds more like it. Yeesh. So now all I need to do is start up the machine, push my tool in until I get a reading on my DRO of 0.088, and I know I'm at the right diameter. So here we go. Yeah, you see how it's gathering up there? That's a classic Delrin move. I'm not too concerned. 0 point. Let me go pretty close. There we go. Oop, yeah, we're doing good. Okay. That's one cut. Clear away the material. Make the second cut. You want to see this. It's a nice cut. Ooh, whoops. Hey, we're good. I'm going to just blow that out. Third cut. Just move this over just a little bit. Boop, 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 like that. I'll admit, this isn't the most ideal use of a cutoff tool, but I learned some bad habits in special effects, and I'm not changing them. clear away some of this detritus. Come on. Looks like, ooh, wow. Now, wait a second. Looks like, oh yeah, okay. I might still be able to get this to work. Yes, yes, I will. Yes, I will. Okay, so, wow, that worked amazingly well. So my measurements were fabulous. I cut in a little too far here. And consequently, I only ended up with this little tiny lip, but that's about all I wanted. So I made a very happy mistake here. So I'm going to just hit this on the bandsaw and we'll test fit it. Did I say bandsaw? I didn't mean bandsaw. I meant belt sander. So like I said, I screwed up, but apparently my screw up didn't bone me because I still was left with a little tiny lip, and that lip turns out to be enough to, oh, that is a sexy story right there. That's kind of all I need. Excuse me, I burped there. That's kind of all I need for this, because I just needed to be strong enough to hold on to that, and it is. So I think this might be one of the fastest one-day builds ever. I think we might be able to put this bad boy back together, and I think we can do it. Yeah, right. Okay, so is there a screw that holds you on? There isn't. Well, let's put you back in there. And we have a top dead center long screw. I'm recording, right? Yes, I am. All right, good. The real trick is going to be, how do I get the shot of looking through this thing? But we'll get to that in a minute. Oh, right. I need, do I need? I don't need. These nylon screws should be plenty. So this comes in here like that, and then those are the little keepers. There we go. Oh, nice. That's a nice piece of equipment. You're a very nice piece of equipment. Okay, tighten down. And then I'm going to get a, yeah. Whoop. I'm going to pop this here like that, and then I'm going to tighten it in. Oh, dude, that is sexy. And I am going to do some strain relief here so it doesn't, so there's not too much weight sitting on that piece. And I'm going to move my fiber optic power supply. Here we go. Here, let's lower this down. Is that right? No, how about that? Hi, Maggie. Okay, so put this into the power supply. So I'm pretty excited about this. Turn it on. Oh yeah, and this should be, oh right, okay, so I should have that set at the bottom. Yeah. Let's see, oh my God. Okay, so depth is, I still need to go down about 1 inch. That's tightened down. Come down there. And then I should be able to, gotta raise my seat a little bit. Ah, I got a taller stool. There we go. Ooh, okay, let's adjust that. Oh, baby. Oh, that is gorgeous. Okay, so let me get one side in focus. Ooh, wow. Okay, yeah. Holy cow. Yeah, I know. You've got to see this. So. Oh, yeah, we're getting it. All right, come on. Let's see if I can get this. Oh, almost. Oh my God, it's so specific. So yeah. So now you can see, yeah, you can see just how close up. This is one of my mini machinist screwdrivers. Oh yeah, there's my fingernail. Oh, and actually, yeah, here's my, ooh, yeah. How about my injured finger? Want to see that? Yeah, you do. Ooh, yummy. Okay, so if I show some part of my fingerprint there like that, and I adjust the focus, there we go. And yeah, I can actually adjust the light all over the place. Ooh, wow. Wait a minute, there's zoom? Holy cow. Hold on. Oh my God. Come on. Ladies and gentlemen, look at that. Okay, that's officially, oh, I forgot that I'd ordered it with zoom. So when I zoom in, it actually changes the focus. So I got to bring this over here. Oh, come on. Yeah, okay. That's pretty amazing. You're welcome, everybody. Thanks for looking at my dirty fingers. Here's a scar tissue. On my finger. Oh, super cool. So there you have it. This is a beautiful ring light, nicely attached to the bottom of my inspection microscope, which has been sitting, languishing for years, really, in storage. And it's backing up and running again. Yeah, well, that might just be the fastest one-day build I have ever done. It's just a single ring connecting two pieces. And this is the kind of thing, like, you don't need a lathe anymore to do that. You could 3D print that. I mean, it might take you a couple tries, but 3D printing is exactly the perfect medium for those kind of tool mods. And I do those kind of tool mods all the time on my tools, attach things to those tools that makes them more useful. And yeah, I get a whole second life out of this. I got to figure out where in the shop that's going to live, because I'm not going to take it apart and put it inside a closet again. It's going to live where you can look at stuff. Thanks for joining me for this one-day build. I'm Adam Savage. This is Tested.com. I'll see you next time. Thanks for watching 100% of whatever you just watched. That's awesome. We get to add that to our completion rate. You deserve something. You deserve a t-shirt for all your hard work. Follow the link below and buy yourself a Tested official t-shirt.